Hello, hello, Angie and Mesa. Sorry, I forgot. So a little bit more and we will start. Okay, so I am going to start checking the attendance right now. Acevedo is here. Alvarez David Santiago is here. Aponte, yes. Arguello, he is not here. Paco is here. Laura Forero, not. Sherazadi, not. Sofía is here. Gabriela, not. Valentina, she's here. Isabela Loaiza, she's here. Sara Lopez, yes. Juliana, yes. Saraide. Martinez, no, she's not here. Alina, yes. Mesa, yes. Majo, yes. Angie, yes. Prada, not. Ramos, yes. Manuela, not. Silva. Does anybody know if Silva has any problems connecting to the classes? I think that he has not been connecting to my classes like for 3 days, and I'm not sure if he has problems or not. It's a lot of people. How many people do we have? 27. Argüello no. Ah, es que claro, yo tengo dos perfiles. Mm, ¿Tres? ¿Salen tres? Solo veo dos, pero bueno. Thank you, Wilches. So nobody knows what happens with Silva? Okay, thank you very much. Okay, so let's begin. Remember, kids, that today our class is of physics, and yes, you need the notebook, Anchi. Eh, and the first thing that I want to talk about is the questionnaire that I asked you to solve last cycle. If you remember, it was this one. This one. So actually, let me open the presentation of magnitudes because I don't have it opened. just in case we need to remember. So that was your grade. Write with your words the difference between base quantities and their derived quantities. Provide three examples. Provide other three examples of derived. Tomás Argüello. Um, and these questions of the units. So let's start checking the answer. So 6A, 6B, anyway. And of course, this combines answers from other classes, but don't worry, I just wanted to talk about the same thing because it's general, right? You see, the answers here, the distribution here was more or less equal, really similar. So, yes, all of the classes that participated here had similar answers also. Gabriela Heredia. Well, so the first question was the definition, with your own words, of the difference between base quantities and derived quantities. So let's check some answers. It doesn't say who answered that, which is great. Eh, Derived quantities are formed from two or more base quantities. Yes, that could be a very simple but accurate definition. The basic ones cannot be taken from another measure, are the primary ones, but the derivatives, if they can be taken from another measure. Okay, okay. This is really bad written in terms of grammar, but I understand the definition and it's quite good. ¿Dónde estaba Saraide? One moment. One moment, a message from the coordinator. Chicos, los invito, de parte de coordinación me dicen que los invite a una izada de bandera que hay el día de hoy a las 9:30. Me imagino que el link les llegará por Fidias, pues es obviamente sobre el día del idioma. De todas formas. Okay, yes, this definition is kind of accurate, even if its grammar is really bad. Um, yes, the base quantities cannot be made from any other quantity, but derived, yes. Let's see from here. Boom. The magnitudes are certain that do not derive from any other. Okay, these are distance, time, mass, electric charge, and there is the quantities are in terms of the fundamental quantities. For example, speed is defined as distance divided by them. Yes, more or less, more or less. Once again, there are issues with the grammar, but no problem. Bueno, para que no digan que no les llegó el link, se los voy a compartir de Fidias, de mi Fidias, para que no digan que no les llegó el link, porque sé que a mí sí me llegó. Ah, Santiago, aquí está. Oh, the performances. Actually, yes, you are right. I didn't give you the performances. So after this class, I am going to take the performances from the lesson plan and I am going to upload them to the Padlet. Thank you, Vargas. I just forgot about that. Yes, there are no performances here. So later I will do it. Thank you, Vargas. Okay, so let's go back to this. Let's check another random answer. But anyway, I already checked those before. Base quantities are those that define what you want to measure, while the derived quantities are those that are obtained by working with the base quantities by multiplying or dividing them. Perfect. That's a really a good definition of base and derived. And uh, the last one actually. The difference is base quantities are quantities that cannot be determined by others. Yes. As length. Archer. Okay. Then temperature, mass. Instead, the derived quantities are achieved by combining base quantities when you multiply, divide, or both. Perfect. Perfect. Really good. So the difference between base and derived quantities are clear. Let's provide three examples of base quantities. Length, mass, time. Perfect. Length, mass, weather. Dios mío, el clima es una magnitud, chicos. What do you think? Obviously not. Okay, you can measure a lot of things from the weather, like the temperature, the velocity of the winds, the acceleration of the winds. Actually, also remember velocity and acceleration are not the same thing. But the weather itself is not a magnitude, a physical quantity. No, no, no. Length, mass, time, pi, gravity, meter. No, those are not quantities, kids. Pi is a constant. It's a number without any magnitude because the pi is just a number. When you can say, for example, that my circle measures pi centimeters, well, that's different. But anyway, the number cannot be a quantity. The gravity is exactly the same than that. Gravity is a constant. Gravity in on Earth, it's always the same, right? ¿Qué pasa? A mí también me gustaría, pero bueno. The gravity is a constant. The gravity is not a magnitude. You can say, and we will see later that the gravity helps a lot when you want to define the weight, because remember, the weight depends on the gravity of the place. But anyway, the gravity in this case is just a constant. It's not a magnitude, something that you can, um, how to say it, measure, because it never changes. The velocity that the gravity gives you never change if you measure something or something else. Okay, and the meter is a unit. The meter is a unit, not a magnitude. Okay, let's check. Okay, this answer, I would like it. When making a structure, when know how much package of potatoes weight, when know how much of apple weight. Okay, when making a structure, you can measure a lot of things, but you didn't specify. Well, that person, I am not sure if that person is in this class or not. When know how much package of potatoes weight, the weight, the weight is a derived quantity because it comes from mass and from force. So no, we wanted base quantities. And we know how much an apple weight, the same. That person gave the same example. But anyway, let's check other answers here, other two answers, and we will move on. Length mass time, meter second kilograms. Ah, okay. Length mass time. Yes, perfect. base quantities. Meter is a unit. Second is a unit. Kilograms are units. Length, time, and mass. Perfect. Meter, kilogram, second. That is units, kids, not the base quantities, not the magnitudes. You have to be really careful. It's not the same telling that I am measuring the distance, which is a magnitude, but it's different than saying that I am measuring the centimeters because you don't measure the units, you measure with the units. It's different. Okay, and okay, let's check this long answer. The quantity is given by a fraction 10 equal parts to. I don't understand this answer actually. I don't understand what this person understood by this question because you just had to give three examples, like most of the people: length, mass, and time. That's it. I don't understand this. So, anyway, let's move towards. I imagine that there are similar answers. Surface, which is area. Yes, that's a derived quantity. Volume and speed. Perfect. Let's check this one. Another time. Kilometers, hours, and tons. No, those are units of the same magnitude. Two kilometers. Ah, no, mentiras. ¿Qué estoy diciendo? No, they are from different quantities. But anyway, they are units, not derived quantities. Here, area, volume, speed. Perfect. Force, volume, speed. Perfect. The force is also derived. Kilograms, meters, seconds, unit. No. Let's check this one. Pressure. Pascal, okay. Power. Yes, that's a derived quantity, even if we are not going to see this magnitude this year. That's a derived quantity. Inductantia. What? I have never listened to this one. Let's check. Let's quickly check. Quickly, what is that? Inductancia. Ah, yes, 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 yes. It's something related with electricity. Yes, yes, yes. I didn't know the term in English. Yes, but I'm pretty sure that this person looked in internet for the first examples that that person found. That's it, because I didn't ask for the unit, I didn't ask for the abbreviation and for the derivatives of that, like where that magnitude comes from. So yes, I'm pretty sure that person looked that in internet. Actually, let's try to find the page that that person used. I'm pretty sure it's this one. Yes, I'm pretty sure it's this one. The only thing is that this person translated, and that's it. Yes, okay, anyway, let's move to other questions. But most of you had the right answers. So this one, let's open the presentation and let's compare with what I put in the presentation. Okay, what is the unit for mass? So unit for mass is kilograms. And yes, most of you had the right answer. Amazing. Yes, plagio, Juliana. Yes. The unit, no, espera. The unit for time. The unit for time is seconds, which is the yellow one. Great. The unit for distance, which is meters, which is the green one. Yes, but okay, be careful because a lot of people answer something that is not right. The main. the main one, because you know that there are more units. But the main one in the international system of units is meter. What is the unit for acceleration? Okay, let's look at the next slide because acceleration is a derived quantity. Acceleration, meters over second square, the pink one, which is good, great. What is the symbol for the quantity of mass? Sistemas mundiales, ¿de qué hablas, Wilches? Okay, so, ya te entendí. Ah, ok, no sé qué me pasa que estoy tan distraído. What is the symbol? The symbol, it's different than the unit. Remember, the symbol is used um, when we are talking about just the magnitude regardless the measures, right? When we use the symbol means that we don't care about the measures or we are not doing any measure. So the symbol for mass, the little m, yes, it's it's here. The symbol for time, which is the lowercase t, yes, most of you answered that. But a lot of you answered the capital T. And remember that the capital T is for the temperature. The lowercase is for time, the capital T is for temperature. And what is the symbol for the quantity of volume? The quantity, the symbol, capital V, which is the purple one. Yes, and a lot of person also answered the lowercase b, which is, remember, for velocity. For volume is the capital, for velocity or speed is the lowercase. So great, kids. A lot of you had a really accurate answers, and that's great. So what I am going to explain right now is a help for you to be able to develop some exercises that I already put in the Padlet. It's really, really short. Let me show you. There are like, okay, here. There are only 2 slides. And the second one is the slide that has the exercises. 5 exercises, only 5 is what you have to do today. But be careful, kids, because for these exercises, now you have to make conversions between units of area and the units of velocity. And the we don't know the conversion ratios. We don't know the equalities. Do you remember when we had the tables? Well, those conversions are not in the tables, and I am going to show you how to get them. So let me open GeoGebra because I am going to make some drawings. Yes, you need to send those exercises to me after you finish all you know that it's through Phidias, right? But don't worry. Oh, pay attention right now. It's not gonna take a lot of time for you, but I really need you to understand how to find those equalities. So let me erase the access. And no, actually, I need the access. Sorry, I forgot about it. So I am going to make a little segment in the 1000. So
Teacher,
today,
¿hasta cuándo es el plazo?
today is 5 exercises.
Ah, for which, o sea, a qué hora, por si algo es que tengo que hacer algo.
Today, Today, Acevedo. Anytime, but today.
Okay.
So, one of the exercises asks you to convert. Let me show you that. Focus on this one. Millimeters squared to meters squared. And you may say, okay, teachers, 1 meter is 1000 millimeters. So 1 meter squared should be 1000 millimeters squared. But kids, this is wrong. It's not the same from linear millimeters or meters to squared meters or millimeters. It's different because there are more dimensions that you have to consider. So remember, ay Dios, you have, ay, ahora se me olvidó dónde está eso. Bueno, anyway, no problem. You have, imagine that this line is 1 meter. Okay, this line is 1 meter. So, how many millimeters are there, kids? Please write in the chat. Imagine that that line is a meter. 1 meter. I am going to change the name. How many millimeters are in 1 meter, please, kids? No me deja cambiarle el nombre. ¿Ya no ves? No importa, Manuela. Es una pregunta que debes saber de memoria. ¿Cuántos milímetros hay en 1 metro? Sara Valentina says 1000. Wow, a lot of people. Well, most of you. Great. A lot of you are really attentive. That's good. So 1000. So let me, if that line of 1000 is a meter, let me make a millimeter. I am going to represent it here. And I am going to change the color just for you to see. I am going to do it green and I am going to do it really thick. Ah, no, verde, listo. Ahora la línea B, segmento G. ¿Dónde está el segmento G? Me estoy volviendo viejo y se me olvida cómo manejar esto. Ok, pero ahí lo ven. ¿Sí lo ven? Ay, Dios. Yes, the process is always necessary, Sara Valentina. Always. So look, that the green is a meter and this one really small is a millimeter. So there is one, there are 1000. See, witches. So that is linear, but we want area for that conversion, kids. So remember, the meter squared is 1 squared of 1 meter. So let me draw that square. Hmm? Dios. Let me draw that square. Ay, espere. Ay, Dios. Ya. Desde acá. There. Ahora sí. So imagine that that big square is a square meter. Yes. So we want to know how many square millimeters are there. But you cannot say that there are 1000 because now let me do the square of 1 millimeter. Hmm? Here you see this square. And if you put 1000 of those, ay, if you what you put 1000 of those inside this big square, you are going to only complete this little small part. Only that little line of the beginning. Como, es como decir, como el primer piso. But how many of those you have to put? How many? 4000 no, pote. 1000. But only this part. You only complete this little part and the rest of the square is empty. So how many will you need? No, which is not that much. It's a lot, but not that much.
Multiply this by 4.
Why by 4?
The green line.
Ok, the green line. Bueno, imagínate que esa línea verde es como la línea de cuadritos de 1 milímetro, ¿vale? Aunque no. Oiga, ¿qué pasa con los vecinos? Están gritando como locos. ¿No les pasa a ustedes, chicos? Bueno, imagínate que esa línea verde es pues una línea de cuadritos de 1 milímetro. If you multiply it times 4, look what is going to happen. I think that you want to multiply it by 4 because there are 4 sides. But you are going to only complete this little part, complete this little part, complete this little part, complete this little part. You make like a, I don't know how to say it in English, but le hiciste como un marco al cuadrito, al cuadrado. But the insides are empty. So you need a lot more. The green line measures 1 meter or, which is the same, 1000 millimeters. How many will you need of squares of 1 millimeter to complete the full square? Mil. Majo, with 1000, you only complete this little part. Okay. No. I am going to make another example. Look. And then we come back to the actual one. Polígono. Imagine that you have a square of 5. And you want to complete it with little squares. Ay Dios. With little squares of 1. How many do you need here? Here you need 5, 5. Listo, 5. If you want to keep filling that, you need to make another floor, otro piso. O sea, otros 5. And how many times?
You need 25.
Espérate. And how many times? do you need to make another floor? ¿Cuántos pisos necesitas hacer?
5.
5 floors of 5 squares. 5 times 5. 5 times 5. 5 así y lo repiten 5 veces así. 5 times 5, 25, right? And if we count, you will see that it's 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 25, right? But it comes from multiplying this measure by this measure. Kids, that's simple. It's the area. So in the case of the big square, Dios mío, este programa me va a volver loco. In the case of this big square, you have 1,000 in this side and 1,000 of this side. So you have to multiply those two measures. Let me do it. 1,000. Ahora porque está con rojo. Bueno, no importa. Times 1,000. 1,000, sorry. Dios mío. 1 meter squared is the same than multiplying 1,000 millimeters times 1,000 millimeters. Yes, 1,000 like this and 1,000 like this. So eso te lo rellena. Pero bueno, ignoren mis rayones. What is the result of 1,000 times 1,000? No es 10,000, pote. Ni Juanita, ni pote, otra vez. Ahí, let's do it. 1,000 times 1,000. 0 times 0. 0, 0, 0, 0. Listo. Ahora para este. 0, 0, 0, 0. Ahora para este. 0, 0, 0, 0. Now for the one. 0, 0, 0, 1. And if you add all of that, it's 1, 0, 0, 0, 0, 0, 0. 1 million. 1 millón, chicos. So, this is 1 million of millimeters squared. That is why here I put that 1 meter squared is 1 million of millimeters squared. Hmm? That is why it comes from, where it comes from, sorry. Yes? Don't say that if 1 meter is 1,000 millimeters, 1 square meter is going to be 1,000 millimeters squared. No, that's wrong. Because the dimension change. Now you increased one more dimension that you have to consider. Ok, chicos, pónganme más atención, creo que están muy activos en el chat con cosas que no tienen que ver, porfa. Ok, so another one that you need is this one. This one works for the third point. And for the fourth point, you need to convert from kilometers squared to meters squared. Yes? So the reasoning is the same. I am going to draw it really, really bad here. If this is a millimeter, no, es, oh, bueno, me quedó un cuadrado, excelente. If this is 1 kilometer squared, how many meters are inside? Well, you can say that inside there are 1,000 meters. So if you want to know how many squares of 1 meter fit here, you have to multiply 1,000 times 1,000 meters, which is the same multiplication here, which is 1 million. 1 kilometers squared is 1 million of meters squared. That is where it comes from. But now let's talk about one like this. We have to convert from kilometers per hour to meters per second. So let me show you where it comes from, and let me change to black because it looks better. From kilometers per hour to meters per second. So we are going to start replacing a lot of things. So pay attention to me here. Kilometers per hour. Esto es una H, no una N. We want to convert it to meters. So 1 kilometer is how many meters, kids? Please write in the chat. 10,000, Vargas. 1,000, 1,000. So 1 kilometer in one per hour is the same than 1,000 meters in an hour. It's the same. We only replaced, but the quantity, the amount of things is the same. Lo mismo. Esto es 1 kilómetro y esto es 1 kilómetro. We only wrote it in a different way. Don't worry, Prada. Now, yes, we have it in meters, but now we need to convert hours to seconds. So let's convert first that to minutes. 1 hour, how many minutes are in an hour? Hey kids, how many minutes are in an hour? 60 minutes. Perfect. Yes? Now, but we need it in seconds. Look, we need it in seconds. So 1,000 meters, but we want to put it in seconds. So how many seconds are in a minute? 60 seconds in a minute, but there are 60 minutes. So you have to multiply 60 seconds 60 times, right? Because 60 seconds, 60 minutes, right? So the answer of that is 3,600. So 3,600 seconds are in an hour. So this is a kilometer. Remember, this is 1 kilometer. And this is 1 hour. We only wrote it with the different units. Yes? So 1 kilometer per hour is 1,000 meters in 3,000 seconds, 3,600 seconds. Let's simplify this number to something like one unique number. So remember, fractions are also division. So we need to make 1,000 divided by 3,600. And the result of that is, let me remember, I don't quite remember. Yes. 2,7777777, repeating 7. So 2,7 repeating. So you can write it like this. 2,7 repeating, or you can make approximations like here. You can say that it's more or less, that is the symbol for approximation, 2,7. Lo dejamos así, ¿vale? So this, everything of this is 2,7. So 2,7, bueno, más o menos, aproximado, 2,7 meters per second. Is the same, miren todo esto, miren todo este proceso que hicimos, is the same than 1 kilometer per hour. 1 kilometer per hour are approximately 2.7 meters per second. Hmm? So here I put it to you. Okay, so now what you're going to do is that you're going to remember these exercises are in Padlet. It's a presentation that says exercises. Ay, Dios mío, esto es con S, perdón. Igual eso ya está mal en Padlet. Anyway, no problem. You have to convert this from centimeters to meters, this from grams to kilograms, this from millimeters squared to meters squared, like using these new units. So please, kids, I want you to do that right now, and please send the results to me in Firias. You have like 40 minutes to complete that. It's really simple. And if you have any questions, I will be paying attention to your questions in Firias. Do you need something right now, kids? Please send the process. Miren, chicos, los voy a decir en español. Si no me envían los procesos, no les digo si está bien o mal. Les respondo, no me enviaste procesos. Y me tienen que volver a enviar las cosas. ¿Vale, chicos? ¿Ninguna pregunta? ¿Seguros? ¿Segurísimos? Bueno, entonces, pónganse juiciosos a hacer eso, que entre más rápido les terminen, pues más rápido quedan libres. Y no olviden asistir a la izada de bandera. Yo les envié el link por chat. Está casi al principio. Bueno, chicos, muchas gracias. Voy a grabar el chat. Thank you, kids. And please, kids, you can already get out of this video conference. Thank you very much. If you have questions, please ask through Phileas. Tell
Hasta
me,
la próxima.
tell me, dime.
Bye, teacher.
Bye bye, Acevedo. Thank you. Okay, kids, I'm gonna kick you out. Thank you. Torres, bye. Ah, listo.